Let's take a look at this problem. We want to find the focus and directrix of each parabola with the given equation, then match each equation to one of the graphs that are shown. So we got y squared is equal to 2x. I know those graphs are pretty light, so I apologize for that. Okay, so y squared is equal to 2x. Now if we review our formulas, we got two formulas. And the top one is when the squared is on the x, the bottom one is when the squared is on the y. So here the squared is on the y. So we're going to use the bottom formula because this one is where the squared is on the y. We'll go ahead and put that here. Now our bottom formula is y minus k squared is equal to 4p times x minus h. So y minus k squared is equal to 4p x minus h. We're going to try to rewrite this so it's in this form. So over on this side, we need, here we just have y squared. We need this as y plus a number or y minus a number squared. I'll choose a minus, so it doesn't matter. And you think of what number can you put here such you don't change its original value? Well, 0 would work. Because y minus 0 is y, and y to the second power would give you a y squared. Now over on the other side, you notice our form always has a parentheses before the x. Well, we can always create a parentheses by factoring out whatever number's in front of our x. So we factor out a 2. Okay, so we got y minus 0 squared is equal to, we'll come back to the 2, but we'll eventually want to rewrite it as 4 times something. Now what's inside the parentheses here, the x? We want it as x minus a number or x plus a number. Well, we can put a 0 there. If you don't already have a number, you can always put a 0, because x minus 0 is x, and that gives us our original value. Okay, now we want to rewrite this as 4 times something. Sometimes it's not always so easy to see how to rewrite that, especially with 2. How do you rewrite 2 as 4 times something? Well, a trick you can use on that is whatever number's right here, you can put up on top of the fraction, and then always put a 4 down below. So again, whatever number's right here always goes up on top, and then you always put a 4 down below. And the reason why, going backwards, the 4's would cancel and you'd be left with the original 2. So now we're rewritten this as y minus something squared is equal to 4 times something times x minus a number. So the number that's inside with our y is our k. So this is going to be our k. And it's always opposite sign, remember. But 0 doesn't have a sign, so k is just 0. Whatever number's inside the parentheses right here is our p. So p is 2/4, or it's equal to 1/2. And then from our form, whatever number's right here is our h. And it's always opposite sign, though 0 doesn't have a sign. So h is 0. Now even though it doesn't ask us for the vertex, we'll go ahead and find it. The vertex is equal to hk, which would be 0, 0. Now our focus. Remember, we're using the bottom formula. So our bottom formula says the focus is h plus p comma k. So h plus p comma k. Well, h is 0, p is 1/2, so 0 plus 1/2. Comma, k is 0. So our focus is going to be 1/2, 0. And that's the first thing they're asking us for, is the focus. Now our directrix. And again, we're looking at the bottom formula. I always write down top and bottom on this so I can keep that straight. Our bottom formula says the directrix is x equals h minus p. So x is equal to h minus p. We said that h is 0 minus p, which is 1/2. So we got x equals 0 minus 1/2, or x is equal to negative 1/2. And that's our directrix. That's the second thing our problem's asking us for. Well, they're asking us then, find a focus and directrix, and then match this graph up to, match this equation up to one of the graphs. So let's go ahead and graph this. Our vertex is 0, 0. which would be right there. Our focus is 1/2 0. And I'll say this is 1. So 1/2 would be about right here. So that's our focus. And if that's 1/2 here, this is about -1 here. And our directrix is x equals -1/2. So I come here to x equals -1/2, and I put my line. And this is our directrix. Okay, now to graph it. I drop a point somewhere. Let's say, look where my point is right here. Look at the distance from my point over to the directrix, forming a 90-degree angle, and distance from my point to the focus. They're not the same. What you do is you keep moving your dot until they are the same. That's probably about as good as I'm going to get, eyeballing it. That'd be a point. By definition, the focus in directrix is if I look at this distance going over here to my directrix, forming a 90-degree angle, and that distance from my point to the focus, those should be the same distance. So if this distance is 1, this distance should be 1. Now we're going to drop our second point. Okay, so I put a point right here. Come look at the distance from my point to the directrix and my distance from the point to the focus. The distance to the focus is a lot larger, so I have to keep moving my point. Doesn't matter where you move it to. You're just trying to move it until the distances are about the same. And that's probably as good as I'm going to get. Again, the distance straight over to the directrix, forming a 90-degree angle, should be the same as the distance to the focus. Now, after you get a couple of points, then you have it. Because you know a parabola is curved, so this is going to be curved, going like this. Now by symmetry, we can flip this down, and that gives us our other part of our graph. So that would be our graph. And that matches D. And those would be your answers.